You ever have one of those moments? You build a machine learning model, it works flawlessly on your laptop, and you think, this is it? Only to watch it just completely crash and burn in the real world? Well, we're about to dive into a story just like that. It's a tale of a super promising AI launch that turned into a full-blown $45,000 nightmare.
So, this was the message, right? A frantic SOS from a startup that had just launched their new AI recommendation API. In the lab, everything was perfect. I mean, predictions were just flying out super fast, like 200 milliseconds. But the second real users started to show up, the entire system just buckled. And not under thousands of users. We're talking less than 50 people.
And the business impact? Oh, it was immediate and it was brutal. We're talking 6 hours of downtime right during peak traffic. Thousands of potential customers just gone. And it left a huge dent in the bottom line. $45,000 in lost sales, just like that. So what on earth went so wrong?
Well, the whole technical crisis really came down to this one kinda insane number, 250 gigabytes. Because of the way the code was written, the server needed that much memory to handle just those 50 users. The tiny little problem? The server only had 16 gigs of RAM. It was literally designed to fail.
You know, what's so wild about this whole thing is how simple the fatal flaw was. If you look on the left, you see the bad code. What it was doing was loading the entire 5 gigabyte model from scratch for every single user request. Insane, right? Now, the good code on the right does something totally different, something that makes all the sense in the world. It loads the model just once when the server starts up and then reuses it for everyone. This tiny change is everything. It's the difference between a total crash and a product that can actually scale.
To really get our heads around this, let's use a super simple analogy that just nails the core of the problem. We're going to compare a personal chef to a vending machine.
The real solution to this whole mess, the professional way to do it, is a discipline called model serving. Basically, it's the art of taking your model from being just a cool science experiment on your laptop and turning it into a tough, scalable product that can handle all the chaos of the real world.
And this table just illustrates it perfectly. That bad code approach, it's like hiring a brand new personal chef for every single customer that walks in. They have to run to the store, buy all the ingredients, cook the meal from scratch, and then they quit. It's unbelievably slow and ridiculously expensive. The vending machine, on the other hand, you stock it up once and it's ready to go. It can serve thousands of customers instantly.
So here it is, the big takeaway, the vending machine approach, which is just proper model serving. It loads your model just one time. That's it. It keeps it warm and ready in memory, so every single new request gets a prediction almost instantly. You build it once and it serves everyone. That's the magic.
Okay, so how do we actually build our own AI vending machine? Let's walk through the playbook that the pros use for model serving.
It really all boils down to 3 key pillars. First, don't reinvent the wheel. Use a dedicated framework. Second, you have to optimize your model for a production environment. And third, once it's out there, you have to monitor it like a hawk.
All right, let's start with optimization. Because here's the thing, the model that works great in your notebook is almost never the one you should actually deploy. We've got to make it smaller, faster, and way cheaper to run.
Now, one of the most powerful tools in our toolbox here is something called quantization. The best way to think about it is like this. Imagine you have a massive 4K movie file. Quantization is like compressing that file into a smaller, good enough for your phone version. Yeah, you might lose a tiny bit of quality, but it's drastically smaller and way faster to load.
And the results can be absolutely staggering. Just look at this chart. A standard model at 2.4 gigabytes becomes just 620 megabytes after quantization. That's a 75% reduction in size. That means way faster loading times and much lower memory costs. But it's not just about making it smaller. The speed benefits are huge too. You can see here that same optimization can take your prediction time from 45 milliseconds all the way down to just 18. That's a 2.5 times speed up, which for user experience is absolutely critical.
And honestly, quantization is just the beginning. There are other cool techniques like batching requests together, which can boost your throughput by 10 times, or converting your model to a universal format like ONNX, which can make it almost 4 times faster. The optimization toolbox is really deep.
So, you've optimized your model, you've deployed it. Your job is done, right? You can just kick back and relax? Absolutely not. This brings us to probably one of the most overlooked yet critical steps, monitoring. This number right here, this should be a massive wake-up call for everyone. A shocking 30% of ML models in production see their performance get worse within just 6 months if they're not being actively monitored. Your amazing model can silently just become useless.
And the main culprit here is a sneaky thing called model drift. This is what happens when the world changes and the new data your model sees in production just doesn't look like the old data it was trained on. It's kind of like a weather model that was only trained on summer data suddenly being asked to predict a snowstorm. It's just going to fail.
So the key is to basically have a health dashboard for your model. You need to be tracking its speed, you need to watch for any signs of data drift, log your predictions so you can debug later, and always version your models so you can quickly roll back if something goes wrong.
So let's just quickly recap the 4 golden rules from all this. First, and this is the big one, load your model once it's started up. Second, always think vending machine, not personal chef. Third, optimize your model's size and speed before you even think about deploying. And finally, once it's live, monitor your model relentlessly.
You know, all of this really brings us to one final, kind of challenging question, because moving from a notebook to production is really about changing your mindset. So take a look at your own projects and just ask yourself, is this just a cool science project, or is it a truly robust, reliable product? The answer to that question makes all the difference in the world.